Earlier this month, the Livestock Improvement Corporation, or LIC, opened its new methane research barn. At 106 metres long and 30 metres wide, with room for up to 120 cows, the multi-million-dollar build is the largest research facility of its kind in the Southern Hemisphere. The farmer cooperative says its research could cut methane emissions from dairy cows by up to 20% over the next 25 years. I spoke to senior scientist Dr. Lorna McNaughton just outside headquarters in Hamilton.
So methane is produced by cattle, or more precisely by the bugs in the rumen that are digesting the plant matter. And it's an important greenhouse gas because it's very potent, although it has a much, much shorter life than carbon dioxide. It's much more active while it's around.
I suppose that's one of the projects that you're involved in, is trying to create what people are referring to as methane-friendly cows. What is it? What is a methane-friendly cow?
So there's genetic variation in almost every trait, and being a genetics company, we are interested in seeing if there is genetic variation in methane and then how we can exploit that to produce a more climate-friendly cow.
When it comes to looking at those genetics, do you think that cows or bulls are more influential?
It's 50-50, so they both contribute equally. But for the methane work we've been doing, we've been measuring the bulls, so that means we can select on the bull side. So we can't currently select on the cow side of the equation.
Are there other sort of characteristics that you're also having to factor in? Things like, I suppose, more heat tolerant cows because climate change is starting to be felt anyway, and also maybe, I suppose, the usual qualities that farmers are looking for in terms of good weighty stock and good temperament?
So the methane work we've been doing to date it's quite early stage research, so it's been all about measuring how much methane they emit, and then we're starting to get to the point now where we need to understand, is a low emitting cow a highly productive cow? Is there any impacts on fertility? So we're just starting to answer those questions now.
Well, how do you test that? How do you measure what a cow's methane input and output is like?
Contrary to popular belief, most of the methane is in the cow's breath. So we have a nifty little machine called the green feed, which is a little bit confusing with that feed in the title, but essentially it's like a giant fan on wheels, and it's also got a big treat box on top of it. So the animals put their head in, it reads their EID tag, and then if they haven't visited the machine for a while, it drops some pellets down. And while the animals are in there, they put their head within the hood, all their breath gets sucked up a chimney, and we measure the methane concentration in their breath over hopefully a 3 to 5 minute period. We allow the animals to visit 5 times per day. I was quite surprised at what the animals will do for a treat. Like, if I was a bull, I might be a bit reticent about putting my head in, but they seem very happy to put their head in to get those treats. It all gets logged together, and then we can look at it in varying different ways. We might average it over a week, or we might average it over a month. We know that there is genetic variation in methane in our population. That wasn't too much of a surprise because there's a lot of work happening in this space overseas, and overseas people have identified there is that genetic variation.
Is that genetic variation across the same breeds of cattle, or is it across multiple different breeds and you see some breeds are better performers than others?
In general, when we're talking about breeding, there's usually as much variation within a breed as between breeds. So although we see some very small differences between breeds on average, within each breed we see a huge amount of variation. So whether you're a Jersey farmer or a crossbred farmer, there should be a low methane bull that you can use. So all the bulls that are coming into our sire proving scheme get measured. So that's Jerseys, Holstein Friesians and Holstein Friesian Jersey crossbred. It's really important we measure the feed intake alongside methane because a lot of the variation in methane is just about how much they eat. We want to make sure that by selecting for lower methane, we're not selecting for animals that just don't eat very much, and therefore there could be negative impacts on productivity.
Are there multiple generations involved in this trial? Have you started that selective process and seeing if you can bring out those genetics?
Yeah, we have. So our bulls are reasonably related. So we will have had some of the progeny of the earlier bulls come through that have been measured. But more specifically, we've been doing some work on generating a daughter population. So we took the highest and lowest 25 bulls back in 2022 and inseminated those bulls into a single herd. The calves were born in 2023, and last year we brought just under 400 heifers up to the LIC methane barn and measured them, and we were really relieved to find that we could find a difference in the methane emissions between the daughters of the high methane bulls and the daughters of the low methane bulls.
Given methane is one of the big challenges, big questions facing the primary sector in relation to climate change and sustainability, how important is it that we realise this and what could it mean for New Zealand farmers?
It's really important that we know whether genetics are an option or not, because if genetics is an option, it's nice for the farmers in that they're not having to make on-farm management changes. There's probably going to be enough of them coming down the pipeline for other challenges. We are hoping by late 2026 to be able to say with reasonable confidence if we think we can release a methane breeding value. It's looking pretty promising at this stage, and certainly overseas countries are releasing breeding values for methane. We started with the bulls because it's a trait you can actually measure on the bulls themselves, so most of the traits in dairy we're interested in aren't expressed in the male line. So that's a nice thing about using the bulls. It also means that we get the data on the bulls before we decide who's going to be used, so we can make that nice early selection decision. But the reality is genetics is a big numbers game, so we need to start investigating how we can get cow measurements and getting some of that data flowing in.
Now, I understand the new barn is also a game changer in this work and will allow you to better understand genetics on the cow side of things.
So it'll have feed intake bins. So they are very uncommon in New Zealand. There's a few research facilities have them. A couple of commercial beef farms have them, but yeah, they're not something you would normally find on individual farms, and that means we can follow each animal's individual feed intake. You can look at when they've eaten, how much they've eaten in each event. Certainly in some sheep work that's happened down at Ag Research, they find that there's some sheep that are like snackers, so they visit quite regularly, have quite small meals, and then there's others are more like gorgers, so they might only visit 3 or 4 times a day, but they have a big feed every time they visit.
LIC's also been working hard to breed more heat-friendly cows, I understand.
Back in 2014, we started doing work around potentially breeding more heat-tolerant cows after the SLIC mutation was discovered, and that's a mutation that naturally occurs in the Senepol breed of cattle, which is actually a beef breed that comes from the Caribbean. And it's called the SLIC mutation because these animals have a much shorter coat than normal, and they really do look kind of slick. You can tell them apart in the paddock. So the idea at that point, we were more thinking of this as something we'd develop for the export market for kind of more tropical countries. But then we started having a look at the kind of climate projections and the number of hot days we're expecting, so days above 25 degrees. And that made us realise that actually this could be something that we need in New Zealand. So the goal of the project has been to bring that SLIC gene into our dairy population. So bringing the SLIC gene in, but trying to not bring the beef characteristics. We're now down to animals that have got 1.6% Senepol blood, and we've got our first bull that's over 500 BW points, which is really exciting for the team. So the next phase of that project is really studying the production of those animals in detail. We know that they are more heat tolerant. On hot days, they're about 0.5 degree to a degree cooler in terms of rumen temperature. This next phase, we'll see what that translates to in terms of milk production. We hope in 2029 that we will have some SLIC genetics in our Premier Sires team that's available for the farmers.
Dr. Lorna McNaughton from the Livestock Improvement Corporation.